Black holes are one of the most mysterious objects in the universe, and their interiors are a subject of intense study and speculation. The central region of a black hole is known as the singularity, where the gravitational pull is so strong that nothing, not even light, can escape. The singularity is thought to be infinitely dense and infinitely small, with all the mass of the black hole compressed into a single point. The exact nature of the singularity is not well understood, and it is believed that the laws of physics as we know them break down at the singularity. Some theories propose that the singularity is not a point, but rather a region of space with a finite size. It is also possible that the singularity is not a physical object, but rather a mathematical concept used to describe the behavior of the black hole. Despite the mysteries surrounding the singularity, scientists believe that it is the driving force behind the immense gravitational pull of black holes. The event horizon is the boundary around a black hole beyond which nothing can escape, including light. Once an object passes the event horizon, it is considered to be inside the black hole, and its fate is sealed. Anything that enters a black hole is pulled toward the singularity and crushed to a point of infinite density. The process of being stretched and compressed as it approaches the singularity is known as spaghettification. Spaghettification occurs because the gravitational pull at the event horizon is stronger at the black hole's center than at its edges. As a result, the object is stretched out like a spaghetti noodle as it approaches the singularity. At the singularity, the object's mass is added to the black hole's total mass, increasing its gravitational pull. The intense gravity of a black hole also warps spacetime, causing time to slow down for objects near the event horizon. This effect, known as time dilation, means that time appears to pass more slowly for observers far from the black hole than for those close to it. It is possible that time dilation could be used to create a form of time travel, although this remains purely theoretical. The extreme conditions inside a black hole make it difficult to study directly, so scientists rely on mathematical models and simulations to understand them. The study of black holes has led to important advances in our understanding of gravity, spacetime, and the behavior of matter under extreme conditions. One theory proposes that black holes could be portals to other parts of the universe or even to other universes entirely. This theory is based on the idea that the singularity inside a black hole could connect to a similar singularity in another location or universe. Another theory suggests that black holes could be the key to understanding the nature of dark matter, which is believed to make up most of the matter in the universe. According to this theory, black holes could be surrounded by a cloud of dark matter that influences their behavior. Black holes are believed to form from the collapse of massive stars, but smaller black holes can also form from the collision of two neutron stars. Neutron stars are incredibly dense objects that are formed when a massive star runs out of fuel and collapses under its own gravity. When two neutron stars collide, they can form a black hole with a mass greater than the sum of the original stars. The merger of two black holes can also create a larger black hole, releasing a burst of gravitational waves in the process. Gravitational waves are ripples in spacetime that are produced by the acceleration of massive objects. The detection of gravitational waves has allowed scientists to observe black hole mergers and study the properties of black holes in more detail. One surprising discovery made through gravitational wave observations is that black holes can have hair, or properties other than mass, spin, and charge. This hair is in the form of subtle deviations from the predictions of general relativity, and it can provide clues about the fundamental nature of black holes. Another theory proposes that black holes could be surrounded by a disk of matter called an accretion disk. The accretion disk is formed from gas and dust that is pulled in by the black hole's gravity and heated to high temperatures, emitting intense radiation. The accretion disk could provide a source of energy for black holes, allowing them to emit radiation even though nothing can escape from their event horizon. Black holes that are actively accreting matter are known as active galactic nuclei, and they can emit vast amounts of energy in the form of jets of plasma. These jets can extend for thousands of light years and are believed to be powered by the intense magnetic fields that surround the black hole. The study of black hole jets and other phenomena associated with active galactic nuclei is an active area of research in astrophysics. Another proposed feature of black holes is the existence of firewalls, regions of intense radiation that surround the event horizon. According to this theory, any object that enters a black hole would be destroyed by the firewall, rather than being stretched out by the black hole's gravity. The firewall theory is controversial, and it remains unclear whether such structures exist in reality. Black holes are also believed to have a temperature, which is determined by the amount of radiation emitted by the accretion disk. The temperature of a black hole is inversely proportional to its mass, meaning that smaller black holes are hotter than larger ones. This temperature is known as the Hawking temperature, after physicist Stephen Hawking, who first proposed its existence. Hawking also proposed that black holes could emit particles through a process known as Hawking radiation. Hawking radiation is a result of quantum effects near the event horizon, and it causes black holes to slowly lose mass over time. The process of black hole evaporation through Hawking radiation is incredibly slow, and it would take trillions of years for a black hole to evaporate completely. As black holes lose mass, their temperature increases, and they emit more radiation, eventually reaching a point where they explode in a massive burst of energy. These explosions are known as black hole supernovae and could be among the most energetic events in the universe. The study of black holes and their properties has implications for our understanding of the origins of the universe and the behavior of matter in extreme conditions. Despite their mysterious nature, black holes are a fascinating area of research, and scientists are continuing to make new discoveries about these enigmatic objects. Thanks for watching. Don't forget to like and subscribe.